Hey guys, welcome to yet another video where you will be learning with me. And today you will be learning about this. So let me get my stuff and let us get started. So this Wiggers diagram is basically related to the cardiac cycle. Now, what is the cardiac cycle? As the name suggests, it's the cyclic events from one heartbeat to the other. And for you to understand the cardiac cycle, I've already made videos. But apart from that, let me just explain to you some important terms. Number one, let us talk about systole and diastole. Systole is basically the contraction of any particular aspect of the heart. As you know, the heart contracts, and this contraction pumps the blood from one compartment of the heart to the other. Now, contraction of any one compartment of the heart is known as systole. Relaxation of any compartment is known as diastole. The second term you need to know about is valves. So now these valves are present in the heart to prevent the backflow of blood. For example, this is the right atrium, this is the right ventricle. Now blood flows from right atrium to right ventricle, but it shouldn't flow back from right ventricle to the right atrium, and valves here ensure that the blood does not flow back. Let us now discuss the basic idea of cardiac cycle so that we understand the Wiggers diagram. Here is a very primitive diagram of the left side of the heart through which I will be explaining to you the cardiac cycle. Now, let's go through the structures real quick so that you understand. This is the left atrium, left ventricle, aorta which is coming from the left ventricle, pulmonary veins which are draining into the left atrium. This one is the left atrioventricular valve which prevents the blood from going from left ventricle to the left atrium. This one here is the tricuspid aortic valve which prevents the blood from going from the aorta back into the left ventricle. So now that you know the general flow of blood, that is from the pulmonary ventricle to the left atrium to the left ventricle to the aorta, and then this goes to the rest of the body and it comes from the lungs. So let us get started with joint diastole. Joint diastole means everything is in the phase of relaxation. So let us assume that this ventricle has just contracted. That means ventricular systole has just taken place. Now after this, the ventricle has to relax, right? Hence, ventricular diastole or ventricle relaxes, and this relaxation is an isovolumetric process. Isovolumetric in the sense the volume of the ventricle remains the same, but the pressure decreases so much because it relaxes. Now the ventricle has relaxed. What happens when ventricle undergoes systole is that the atria is filled with blood because of the pulmonary veins. The pulmonary veins keep filling the atria with blood while the ventricle is undergoing systole. Basically, when the ventricle is undergoing systole, all these valves are closed. And that is why the blood which is being filled in the atria does not enter the ventricles even then. So here we talk about atria being filled. So now, pressure in the ventricle has decreased due to relaxation. Pressure in the atria has increased due to filling. Now, because of these two events, this valve, AV valve, opens due to the pressure difference. There is high pressure here, there's a lower pressure here. This valve opens, the blood flows from atria to the ventricle. Now, this blood flow happens in 3 stages. Number 1, period of rapid filling, which is fast and it causes all the blood to push through due to the pressure into the ventricle in a pretty quick manner, that is 1/3 of whatever filling is taking place. That is 1/3 the time of how much time it requires for the entire ventricle to be filled. Now this period of rapid filling causes the ventricular volume to increase. Then you have a period when blood directly goes from the veins into the ventricles. And the third one is the atrial systole. Now if you remember what systole is, it is the contraction of atria. So atria does not contract for this rapid filling and direct filling to happen. The atrial contraction only acts as an extra pump. So this atrial systole causes increase in pressure of the atria, and it causes the final 20% of blood that is left in the atria to move into the ventricle. Now this one again causes ventricular systole. So when ventricular systole happens, pressure in ventricles increases, and this pushes close the AV valve. This pushes the AV valves closed, and when these AV valves close, you get the first heart sound. So we mark it this way. Now, after this, ventricles contract isovolumetrically. Just the way they relax isovolumetrically, they contract isovolumetrically. That means their volume remains the same, but the pressure increases in the ventricles. And once the pressure increases beyond 80 millimeters of Hg, it pushes open the aortic valve, which causes the ejection of the blood from the ventricle into the aorta. First, it is in a rapid phase wherein 70% of the blood is ejected, and then it is followed by a slow phase when 30% of blood is ejected into the aorta. Now again, we come back to this phase when the ventricle undergoes isovolumetric relaxation. When isovolumetric relaxation takes place, I told you that the pressure decreases but the volume remains the same. Now, the high pressure in the aorta tries to push back the aortic valve and come inside. This is because the pressure is decreasing in the ventricle, the pressure is the same in the aorta, and hence the blood tries to come back. And this small period of the blood trying to come back is called protodiastole. And after that, the aortic valve closes. This leads to the second heart sound, which is denoted by this. And now this again leads to the same set of events which we began with right here. Here I will be drawing the Wiggers diagram and finally will be explaining it to myself. So in this diagram you have three main components. One is the pressure, one is the volume, and the other one. So I will finally be drawing the Wiggers diagram on this piece of paper, and it has three components: the pressure, volume, ECG and PCG. Now I'll explain everything. Pressure is the pressure changes in the ventricle, which I'll be denoting with blue color, then in the atria with pink, and in the aorta with green. Volumetric changes only in the ventricle, and finally ECG, that is the electric changes or electrocardiogram, and PCG or the phonocardiogram or the heart sounds. You can again check out my video on ECG for a basic idea. So let us start with this phase. This phase is isovolumetric contraction of the ventricle. Alright, so when there is isovolumetric contraction, immediately after that you see that the aortic valve opens. After that, this entire period is when ejection of blood takes place from the ventricle into the aorta. And after that, the aortic valve is pushed close by the blood that is flowing back from the aorta. And this period is also the period of isovolumetric relaxation. Finally, we have this entire phase, which is for the filling of the ventricle. As I told you, for the filling of the ventricle to occur, firstly, the AV valve should open. Then there is a rapid inflow of blood from the atria to the ventricle, followed by the direct flow of blood from the veins into the ventricle, followed by this period, which is the atrial systole. Atrial systole is when the atria contracts and the final pump to the blood is given. And again, we are back to this phase. And for us to get back to this phase, the AV valve should again close. And this AV valve closes due to the increasing pressure in the ventricles. So once you get the ventricular graph correct, you can get the rest of the graphs very easily. Let us start with this. Isovolumetric contraction. So in this, the ventricle is contracting. So the pressure is increasing. So let me increase the pressure from around 0 to this point. The pressure still increases even if the aortic valve open in order to pump all the blood out. So the pressure increases and gradually in the middle, it starts decreasing as the amount of blood in the ventricle starts decreasing. And it reaches the same level again when isovolumetric relaxation takes place or the pressure in the ventricle drastically decreases. You can see in this phase. Now, during this phase of rapid and direct filling, there isn't much change in the ventricular pressure, but during atrial systole, when you get that additional pump, there is a slight increase in the ventricular pressure. Followed by the same events again, AV valves close due to the increasing pressure, and hence you get the same graph again as you got it here. And you can see that the pressure increases up to 120 mm of Hg. Now it's very easy to mark where atrial pressure differences occur. Atrial pressure differences occur mainly in 3 areas. Number 1 is called the A wave, which is caused by atrial contraction. Now, where in this graph can you see atria contracting or atria undergoing systole? That is in this phase. And hence, there is a very slight increase in pressure in atria. Now, the second thing is called as the C wave. So, C wave occurs when the ventricles contract. So, when the ventricles contract, they push the AV valve backwards and that causes increased pressure in the atria. So, the ventricles are contracting here and this is the C wave. And finally, we have the V wave, which is towards the end of ventricular contraction, and it occurs due to the slow flow of blood into the atria, which is about here. So these are the only 3 pressure changes in the atria, and then you join them by lines and you get the atrial pressure graph. Now talking about the aortic pressure graph. So I will tell you it ranges only between 80 to 120. That also explains why our blood pressure is in between 80 to 120 and why is it called diastolic and systolic pressure. So when this aortic valve opens, blood is ejected into the aorta and hence the pressure in the aorta obviously goes up and comes down again due to the decrease in ejection. And now this aortic pressure undergoes something known as protodiastole, which I explained before, in which the blood tries flowing back into the ventricle. That is indicated by this small flow back, followed by a gradual decrease back to 80 until another ventricular systole takes place and the pressure increases. Now the ventricular volume graph is the easiest ever because what do you see here? Isovolumetric contraction. So isovolumetric in its own says the same volume. So the graph here will be straight. Now what we have to decide is if it's going to be 120 or 50. Now isovolumetric contraction only takes place when the ventricle is completely filled, and that is why when the ventricle is completely filled, its volume is 120 ml, and this is the isovolumetric contraction, followed by a gradual ejection. So now blood is going out, right? So it is ejected, 70 ml of blood is ejected. So when 70 ml goes out of 120, you get 50 ml. So the graph slowly falls down to 50 ml. Again, there is isovolumetric relaxation. So you have the same volume here again. Now, the volume in the ventricle is slowly increasing due to rapid inflow followed by direct inflow and followed by atrial systole into the ventricle. And this final pump increases the volume a little bit more and you again reach 120. And here again you have isovolumetric relaxation and the graph goes so on. Now this is the ECG. So let me just summarize ECG basically for you. The P wave indicates atrial systole, the QRS complex indicates ventricular systole, and the T wave indicates ventricular or total diastole. So I said P wave indicates atrial systole. So now this ECG signals need to reach the atria before it starts contracting. So before atria starts contracting, that is near the atrial systole, you will have your first P wave, that is before the atrial systole, somewhere here. Only when this signal pass on to the entire atrial musculature, that is when the contraction takes place. Now, QRS complex is before ventricular contraction, that is here. So, the QRS complex needs to be here. And then you have the T wave. The T wave is before ventricular depolarization or ventricular relaxation. Now, systole, depolarization, all these words are again very well explained in several videos on YouTube. Please go check them out. So coming back, you get your T wave somewhere here right before the ventricle relaxes. Now, what did I tell you all about the heart sounds? First heart sound is when the AV valve closes. So that is about here, and if we put it over here, we get the first heart sound here. The second heart sound is when the aortic valve closes and you get the second heart sound here. And this, guys, is the complete Wiggers diagram. The diagram that I've been trying to understand for so long, but I haven't been able to because, bro, I don't know. It was so simple all along. So that was it for today's video, guys. I know it was kafi lamba, but I'm sure you learned a lot. If you didn't understand anything, please do let me know. I will clarify all your doubts. Also, you might think I'm wasting paper, but trust me, guys, I use them yet again for doing random calculations and notes. Apart from this, I was also thinking I'll go for a Q&A session. It's been pretty long, so please drop in your questions. With that, I'd also like to inform that I will not be posting as often as before because of several reasons, in fact. And I will also not be as active on my Instagram. So if you have any doubts or questions, please do post them in the YouTube comments and or email them to me. I'll try to answer most of them. But for many other reasons, for my mental health purposes, I've decided that I wouldn't be much active on social media.